Hi everyone, Ethan Sakaransky here, wanting to talk a little bit today about some of the big things that are going on with the oceans and the bigger climate pictures that are going on right now, because there's some pretty interesting things going on. So I want to talk about why I believe, and some other climatologists and meteorologists are talking about why we think that the La Nina is peaking around now. And the negative phase of the Indian Ocean dipole may also be peaking kind of in tandem with the peak of the La Nina right now. And then talking a little bit about the oceanography surrounding this idea. So, looking at the sea surface temperature, the latest weekly data from today, November 10th, the anomalies are anywhere between minus zero point 0.2 in the east to about minus zero point 0.7 in the west. And this is pretty much the strongest that we've seen the La Nina this season so far. And there's some reason to believe that we're getting near the peak now. So this is actually a visual look at the sea surface temperatures. You can see the kind of basin-wide La Nina off the west coast of South America. It's not west-based, which is if the cool water would kind of be centered west of 150 west, or east-based, where it would be kind of very close to the coast of South America. It's more uniform across the tropical Pacific. And then we can see here all this warm water closer to Indonesia and what we call the maritime continent. And if you look at the modeling, essentially November is the month on most of the models where the La Nina is at its lowest, at its peak. And then after here on out, the modeling is showing a weakening of the La Nina state, and then perhaps going towards more of an El Nino as we get into the spring and into next summer. And from a wind anomaly perspective, we've seen kind of these easterly winds across the tropical Pacific, which has helped maintain and strengthen the La Nina. And moving forward into the forecast period, this is the European AI model, it continues to have some easterly winds just east of the international date line, which may allow the La Nina to continue to maintain its strength over the next month or so, which I think is reasonable. But if we look further towards the west, we can see this large, here in red and yellow, westerly wind push that is starting to form, set up, and strengthen near Indonesia and coming eastward into the western part of the Pacific. And this is kind of going to be the catalyst to begin to move that warmer water east into the Pacific and begin to erode the La Nina in the months ahead. And here's the European ensemble, which kind of has a similar idea, with this overall large pool of westerly wind that's starting to build from eastern Indian Ocean and moving in towards the Pacific. And then if we want to think about, is this going to be considered an official La Nina when we look back? Usually the definition is we need to have 3 tri-monthly periods of negative 0.5 or less. So the tri-monthly period of August, September, and October here, it did hit the threshold of minus 0.5. We're still waiting for September, October, November to come out. October, November, December, etc. And we'll probably be on borderline there of a weak La Nina event. But as far as the current look goes, it's consistent with a weak to a moderate La Nina right now. Even if the event doesn't necessarily hit that officially, the conditions that we're seeing from a sea surface temperature perspective right now on November 10th are consistent with a La Nina. And then looking at the Madden-Julian oscillation, so the thunderstorm activity in the atmosphere, there was this large event that started in the Indian Ocean in the middle of October that has moved towards the maritime continent as we're getting now over the past couple of weeks, really, and continuing through to today. And then moving forward into the forecast period, it looks like this MJO event wants to get into the West Pacific. And sometimes, a lot of the time, it can be difficult to forecast whether or not the event crosses over this landmass that we call the maritime continent to get from Indian Ocean to West Pacific. But there's some modeling support that supports that, which essentially indicates as we go further towards the end of November and beginning of December. And this type of setup, typically phase 7 is when the convection has crossed over into the West Pacific, and that's oftentimes associated with a colder than normal period across eastern North America at this time of year. A lot of the modeling does support that. And in these easterly QBO years like we're seeing right now, convection is enhanced over the equator, and that would support the idea of making these events more likely to cross over from the Indian Ocean into the West Pacific. And that does lend some support to the colder than normal December idea. And looking at the Indian Ocean Dipole Index, there was a peak here in November, and there's some indication now that we're starting to come out of the peak. Oftentimes with these events, they often peak in October or November, like we could see back in 2022. So what's interesting is to see the Indian Ocean dipole peaking at a similar time to the La Nina, and we're probably heading now into closer to going to be warming these temperatures up as we head further into winter. So this brings us to looking a little bit at the oceanography that relates here to the climate. Essentially, from my experience, it's important to have a good understanding of the oceans if you want to have an understanding of the global climate. And the reason for that is because obviously the ocean and the atmosphere, they're coupled, they're connected very closely together. And one interacts with the other, and it's important to have a good understanding of the oceans and the atmosphere to understand how they work together. And there's a few examples kind of on the globe where we have multiple large ocean basins that kind of come together and interact. And one example would be in the Southern Ocean around Antarctica, which is essentially where the large oceans all come and meet. So the Atlantic, the Indian, and the Pacific meet around Antarctica in what we would call the Southern Ocean. And there's no exact point where we go from Atlantic, Indian, or Pacific to Southern Ocean, but that's kind of the process that takes place where all of the global oceans are connected. And this example that I have here, the Indonesian through flow, is another example of where you have two large ocean basins coming, and this is a region that we look at to see how the two are interacting. So the Pacific here on the right, and then the Indian on the bottom left, these currents that move through Indonesia and New Guinea and these islands that make up what we would call the maritime continent allow water to flow between the Pacific and the Indian Ocean. In a normal state of the climate, these currents flow from the Pacific to the Indian Ocean. And that's usually because the Western Pacific, the ocean surface height is higher than the Indian Ocean. So we get a flow from higher surface waters to lower surface waters. So that is the usual state of these through flows that we see. And connecting that to what we're seeing in the climate right now, this is the monthly anomaly eastward seawater velocity that we saw on July the 1st. So this is the average of the whole month of July. And we can see here these blues indicate surface water going from east to west. And if we look at these islands in the maritime continent, the flow is from Pacific to Indian Ocean, which is what we expect in a normal climate state. And then we can see in the Indian Ocean, there's also water flowing from east to west as well. Moving forward to August the 1st, same thing. We see what we would see as a typical flow from West Pacific to Indian Ocean. But notice some of these east flowing water beginning to build here in the Indian Ocean. Moving forward into September, it's kind of the same appearance as we saw in July and August. And then here is October 2nd. This is a daily value because past September we don't have any monthly data, but here's the daily data, still very similar look. And then this is when things start to change. Around October the 10th, we start to see some of the west to east surface current start to build. And now we really see it starting to change here 16th of October. And this corresponds with when the MJO event started to build off in the Indian Ocean as well. And the two are obviously related. Now notice it's building even more. October the 26th. These currents moving across the Indian Ocean. And by today, by November, notice here a reversal of the Indonesian Throughway currents, such that now we're seeing the currents moving from the Indian Ocean into the West Pacific, whereas before it was the opposite. So this is against the climatological average of what we would expect. And so what does this do? This moves all this warm water that we've seen in the eastern Indian Ocean with this negative Indian Ocean dipole event starting to be transported now into the West Pacific. And this is going to start to erode the La Nina event as we head deeper into winter. This is one of the key drivers of that change. So this is a good example of how the oceans and the atmosphere are very closely interacting together, and they're both important to pay attention to. So looking back, here's again, as we look towards the middle of October, this is when that MJO event started in the Indian Ocean, and this corresponds with what we saw in the ocean current and the reversal to this big push of water coming from west to east. Why? Because with an MJO event, it's going to encourage westerly momentum to coming in from the west of the convection, and it's going to allow this westerly momentum to move across the Indian Ocean, and then as it moves more into the maritime continent, to begin to flow through those passageways. And moving forward, this big setup of westerly momentum is going to allow, I believe, the La Nina event to start to break down as we go towards the months ahead. And I want to give some credit to Eric Webb and Paul Roundy on Twitter that were also talking about this, and this brought this idea to my attention. And they were talking about why they believe that we could be in for a breakdown of the La Nina event, and looking at all this data definitely supports that evolution. Looking at the subsurface temperature anomalies here, this gray here, this is where the maritime continent is set up. So this is Indian Ocean here, and then this is all Pacific. We can see that there's a connection between the two ocean basins, and we're starting to see all this warm water from the eastern Indian Ocean starting to flow more into the Pacific, and we're going to start to see changes most likely within the La Nina event as this continues to progress. Now, I did a bit of analog analysis at looking at years with October or November Indian Ocean dipole less than minus 0.5 and what they looked like in December. And in those years, there was a lot of blocking in the western Alaska Aleutian Islands, bringing in quite cold conditions to much of North America. And that's consistent with what we're seeing on the long range models. This is week one. Most of the blocking is set up towards Greenland, but as we go into December, we'll see this start to transition. This is week two, still in Greenland. But watch as we go now into December, first week of December, it's transitioning to this Pacific Western Arctic Ocean blocking, which is going to bring very cold air into North America if it's correct. And this would be consistent with those analog years, negative Indian Ocean dipole years. And this is second week of December, same thing. Very cold air coming down into North America because of this blocking that's transitioned from Greenland towards the Pacific side. So could be a cold December on the way, and that's the video for today. I wanted to look more on the oceanography side of things because I think that from a climate perspective, that's going to be a big driver in terms of the changes that we're starting to see in the El Nino Southern Oscillation. We haven't seen an El Nino since that 2023 event. So last winter was a La Nina. This winter looks like a La Nina, which is two La Ninas in a row. And in the past decade, there's been a lot of La Nina activity. So there's definitely some evidence and mounting data that is going to support maybe a transition out of the La Nina as we head towards the next springtime. So thank you so much for watching. If you have any questions, feel free to let me know.